Hello everyone, welcome to the class of chemistry. In previous few sessions, we have discussed about the first chapter of your class of subject chemistry. And in today's session, we are going to start with the question answers that are given in your book. So, let us get started. The first question that is asked to you is, state the information conveyed by the following equation. Equation is given to you, that is zinc is reacting with hydrochloric acid to produce zinc chloride and hydrogen gas. Second is write the limitation of reaction given in the above question. First of all, you need to tell that what information you are getting, what kind of information you are getting by seeing this particular equation, and in the second part they are asking that what are the limitation of this particular reaction. So let us see the answer here. So how would you write the answer? First of all, let us talk about the information that you can seek by seeing an equation that is given to you. First of all, this chemical equation shows single displacement reaction. How we can say that this is a single displacement reaction? Let us write this equation here also. The equation was zinc plus HCl. I am writing the unbalanced equation although. Okay, that gives out ZnCl2 plus H2. Let me balance it, then it will be 2HCl here. How it is single displacement reaction? Because if you will see that zinc is replacing the hydrogen here and forming the compound with chlorine, forming the zinc chloride. So first of all, which type of reaction is this? This is a single displacement reaction. One single element displaces the other one. Okay, in which a non-metal is displaced by a metal. That means here zinc is being displaced. Hydrogen is being displaced by zinc. So yes, zinc is a metal which displaces a non-metal, that is hydrogen. Okay. Here non-metal is hydrogen which is evolved as gas. So yes, we can say that this is the gas which is being evolved. This is also an information that you can seek from this given equation, right? It is displaced by metal zinc. Yes, obviously this hydrogen gas is actually displaced by the zinc metal. In the given equation, zinc plus hydrochloric acid gives out zinc chloride and hydrogen. Zinc is a reductant metal that displaces hydrogen from aqueous solution of hydrochloric acid. So zinc is actually acting as a reductant metal. Okay. Second, the second part was asked to you that what is the limitation here in this particular given equation. So limitation is HCl will be the limiting reagent. This is the HCl is the limiting reagent in the reaction and zinc will be the excess reagent. That means HCl is present in limited amount whereas zinc will be present in excess amount. Okay. So this will be the proper answer for question number 1. So now we will see question number 2. It is balance the following equations, right? So we are going to randomly pick this and we are going to do this D option here. If we will see the equation, so equation is Fe2O3 plus carbon monoxide that gives out Fe plus CO2. Let me write this equation for you. That is Fe2O3 plus carbon monoxide plus gives out Fe plus CO2. We are balancing this by hit and trial method. Okay, hit and trial method. So for balancing with hit and trial method, what we need to do, we need to draw a table here. That is the table for elements, then reactants, then products. In the section of elements, we will write the symbols of all the elements that are present. So that is iron, oxygen and carbon. Now on the reactant side, we will count the number of atoms of that particular element. For example, iron is present as 2 atoms. Here total 4 atoms of oxygen are present and for carbon there is 1 atom only. Product side only 1 iron atom, oxygen total 2 and then here carbon is also 1. So we need to first, what we need to do, we need to balance the iron. In order to balance the iron, we can multiply this side by 2, right? So what will happen here? We can write this as 2Fe, okay. Next we need to balance the oxygen. How we are going to balance the oxygen? Here it is 3, here it is 2, sorry, here it is 3 plus 1, 4, and here it is 2. So if we are going to do 2 here, that is not going to work, okay. So what we can do is put 3 here, okay, and put 3 here. If you can see, so 3 plus 3, 6, so total oxygen atom will be 6, and here we have multiplied by 3, so it is also 6. Now here it is being multiplied by 3 and it is being multiplied by 3. Now if you will calculate, so total 2 atoms of iron, 2 atoms of iron, okay. Total 6, 3 plus 3, 6 atoms of oxygen, 3 2s are 6 atoms of oxygen. 3 into C, 3 into 1, that is 3 atoms of carbon, and here also 3 atoms of carbon. So your final balanced equation will be Fe2O3 plus 3CO plus 2Fe plus 3CO2, okay. Your total final balanced equation will be like this. So you can use this particular method to solve all the equations that are given in your questions, okay. And the final answers of these equations are given here also. We have solved D, so we can match this. Fe2O3 plus 3CO gives out 2Fe plus 3CO2, okay. So these are the answers of all the balanced equations, okay, that are given to you. You can use this particular method or the partial equation method to solve these equations, and you can match your answer with the given answers, okay. Now let us jump to question number 3. The question number 3 states that sodium chloride reacts with silver nitrate to produce silver chloride and sodium nitrate. Write the equation, first option. Check whether it is balanced. If not, balance it, okay. Find the weights. Weights means here, find the mass, you can also say, of reactants and products. State the law that this equation satisfies, okay. So first of all, you need to write the equation. So how you are going to write this equation? If we see the answer, so here sodium chloride, that is NaCl, is reacting with silver nitrate, that is AgNO3, forming sodium nitrate and silver chloride. This is the equation. Here you can see the downward arrow, right? So this downward arrow means the precipitate has been formed out of this reaction. So this reaction can be the example of precipitation reaction also. Yes, it is a balanced reaction. If we will see, one atom of sodium, one atom of sodium, one atom of Cl, one atom of Cl, one atom of Ag, one atom of Ag, one atom of nitrogen, one atom of nitrogen, 3 atoms of oxygen, and here also 3 atoms of oxygen. So it is balanced. Weights of reactant, if we calculate the weight here, so NaCl would be 58.44 and AgNO3 would be 169.87. How you are going to calculate the molecular mass? We have already discussed this. I will give you the example for NaCl. You will add the mass of Na and Cl together to find out the mass here, okay. So you will add this and you can have this mass. Mass of products, NaNO3 84.99 and AgCl 143.32. When you are going to add this NaCl plus AgNO3 and NaNO3 plus AgCl, so you will get this mass, right? 23 plus 35.5, that will give you 58.5. Instead of writing 58.44, we will write the round figure, that is 58.5, okay. And also plus AgNO3. So for AgNO3, you are having silver 108, nitrogen 14 and oxygen, 3 atoms of oxygen, that is 48. So that will give you 170 in the round of figure. This is the exact mass that is given, but for the calculation's sake we are writing here the round figure. Okay. Now again, so here also sodium nitrate, if we talk about sodium nitrate, mass of sodium in addition with mass of nitrogen and in addition with 3 atoms, mass of 3 atoms of oxygen, okay, 85. Here we have taken the exact atomic mass, but for the sake of calculation we are rounding off here. And also 108 plus 35.5, so it will be 143.5. Here also we have calculated the exact amount, so you can also consider it as 143.5 instead of going with the exact amount, because that is beneficial for us for the calculation part. Okay. So here we can see the mass of reactant is equal to the mass of product. For example, it is 228.5 grams. Now which law says this, that the mass of reactants should be equal to the mass of products? So this is stated by the law of conservation of mass. This is the law which states that after the reaction, before and after the reaction, the mass of reactants will always be equal to mass of products. That means mass can neither be created nor destroyed. Okay. So this is how you are going to solve your question. Now if I talk about another question here, what information does the following chemical equations convey? Chemical equation 1 is given, Zn plus H2SO4 gives out ZnSO4 plus H2, Mg plus 2HCl gives out MgCl2 plus H2. What are the information you are getting from it? How you are going to write it? So this equation shows the result of chemical change. First of all, obviously, if there is a chemical reaction, then chemical change is taking place. When one molecule of zinc, because it is written as Zn, so we will say that it is one molecule, and one molecule of sulfuric acid, that is H2SO4, okay, reacts, it results in the production of one molecule of zinc sulfate, that is ZnSO4, plus one molecule of hydrogen, that is H2. Okay, so this is the information we are getting out of it. Second equation, this equation shows that reaction of magnesium with hydrochloric acid, which gives magnesium chloride and liberated the hydrogen gas. For example, Mg plus HCl, that will give out MgCl2 plus hydrogen. Okay, so this is the equation. This is the equation. These are things that these equations are conveying to you. Also, if you want, you can add some of the points. For example, what you can add is, let me tell you what you can add. You can tell that this is a single displacement reaction, right? You can tell that this is a single displacement reaction, right? You can see that also, and here also it is also the example of single displacement reaction. This is the example of single displacement reaction, and you can say in this particular reaction, acid is being reacted by the metal, and here also acid is being reacted by the metal. Okay, so these are some of the information that you can get from a given equation. Okay, now let us talk about another question, that is question number 5. What are polyatomic ions? You need to give 2 examples. Name the fundamental law involved in every equation. Again, we have discussed this in the previous question, that one fundamental law that is involved in every equation is law of conservation of mass. Now, what are polyatomic ions? Such ions which contains more than 2 or more than 4 ions. Okay, usually what happens that we say that it is monoatomic. Monoatomic means it contains one atom. If we say monoatomic, okay, so we say that means it contains one atom. For example, Na positive. Okay, if I say diatomic, it contains 2 atoms. Okay, it contains 2 atoms. That particular ion will contain 2 atoms. For example, OH negative. Okay, Triatomic, it will contain 3 atoms, right? Tetraatomic, it will contain 4 atoms. And more than 4 atoms, we will categorize as polyatomic. Although technically, if any ion has more than 1 atom also, we can technically say that it is also polyatomic ion. Okay, let us see the answer here. A charged ion, when we are talking about the ion, it is charged, whether positive or negative. Okay, a charged ion that consists of 2 or more covalently bonded atoms are known as polyatomic ion. For example, calcium carbonate, magnesium sulfate, etc. Okay, for example, if I talk about NH4 positive, so this is also the example of polyatomic ion. Okay, fundamental law involved in every equation is the law of conservation of mass, as I have already told you. Okay, so better than instead of giving these examples, this example is more better, far away better for the example as polyatomic ion. Okay, now let us talk about another question here, that is question number 6. What is the valency of fluorine in CaF2, sulfur in SF6? We have studied how we can make the formula, right? So if the formula is CaF2, okay, so how the formula is made? By crossing over the valencies. That means valency of fluorine will be given to calcium and valency of calcium will be given to fluorine. Let me remind you, calcium's valency is 2, fluorine's valency is 1. When we have cross multiplied it, then we have given this formula. We have made this formula, right? So if we want to know the valency of fluorine here, so we will consider that valency of fluorine is 1, right? So valency of fluorine is 1. If I am talking about SF6, so SF6 will be made as sulfur with 6 valency and fluorine with valency 1. So that will make SF6. So what is the valency of sulfur in this particular formula? That is 6. Okay. Phosphorus will be 3. Carbon will be 4. Nitrogen in the following compound, N2O3. What is the valency of nitrogens here? The valency of nitrogen in first will be 3. Why? Because again N2O3 will be obtained by cross multiplication. That means N will have 3 valency, oxygen is having 2 valency. When we cross multiply it, then we get N2O3. So the valency of nitrogen will be 3. In this case, the valency of nitrogen will be 5. In the similar way, you will find for NO2 and NO. With manganese in an MnO2, you will find with the similar way. If we talk about copper here, so the valency of copper will be 1. If we talk about again the valency of copper, it will be 1. Magnesium, it will be 2. Okay. So this is the way how you can find it, right? So answer here is given like this. Okay, when we are talking about valency, let me tell you, when we are talking about valency, we do not need to put these plus or minus sign. Okay, when we are putting this plus and minus sign, that means we are talking about the charges. Okay, there will be plus and minus sign only when we are talking about charges like plus charge or minus charge. But if we are talking about valencies, then we will only write the numbers, alright, in the similar way. So this is basically a charge. So positive or negative sign is not that much needed. What is needed is the number here. The answers are given here to you. Okay. Now if we talk about question number 7. Why should an equation be balanced? Explain with the help of simple equation. What is the need of balancing the equation? Why do we balance these equations? Why do we study balancing of equations in this particular chapter or in class 9th. An equation should be balanced to make it comply with the law of conservation of matter, or you can also say mass. What is law of conservation of mass? What it states? It states that matter is neither created nor destroyed in the course of a chemical reaction. That means no atom, nothing, any type of matter cannot be created or destroyed in a particular given reaction. An unbalanced equation either deletes or adds extra atoms in the equation. For example, if we take this, so here is one atom of potassium, one atom of potassium, one atom of nitrogen, one atom of nitrogen, 3 atoms of oxygen, 2 here and 2 here, 4 atoms of oxygen. This is the unbalanced equation, and this does not comply with the law of conservation of mass, right? In this equation, number of atoms in the left and right side. Left side means reactant side, okay, and right side means product side. Left and right side are not equal, hence balanced equation will be written as 2KNO3 gives out 2KNO2 and O2. Now these have all the atoms of all the elements present in this equation equal, okay. So I hope you have understood this answer as well. Now let us talk about question number 8. Write the balanced chemical equation of the following equations. So these are basically word equations that are given to you, okay. These are the word equations that are given to you. You need to write the balanced chemical equations here, okay. Sodium hydroxide plus sulfuric acid gives out sodium sulfate and water. Here if I write this, sodium hydroxide means NaOH, sulfuric acid means H2SO4, okay. Sodium sulfate means Na2SO4 plus water. And then first of all you will write equation like this, then you are going to count the number of atoms to see if they are equal or not. 1 Na, 2 Na, you will put 2 here, okay. Then 2 oxygen and 4 oxygen, total 6 oxygen, and here 4 oxygen and 1 5 oxygen. Here 2 hydrogen, here also 2 hydrogen, here 2 hydrogen, here 4 hydrogen. So we will put like this. Now the equation is balanced, okay. So first of all you will write the equation by reading the word equation, and then you are going to solve it. So you will do this in 2 steps, okay. Similarly, potassium bicarbonate, that means KHCO3 plus sulfuric acid, that means H2SO4, okay. Potassium sulfate, that means K2SO4, and carbon dioxide, that means CO2 plus water, that means H2O. So you are going to write equation like this, then you are going to solve it out, okay. So let us solve it out means balance it out. So let us do that. 2 potassium here, 2 potassium here, 2 hydrogen here, 2 and 2 hydrogen, total 4 hydrogen. So we have done it. 2 3s are 6 plus 4 10 oxygen here, okay. And here if I talk about 4 and 2 and 2, total 8 oxygen here. So you need to do something about it and you need to balance it further. I am just giving you the way, I am just making you understand how you are going to do it. I am not going to solve this whole equation again, okay. So these are the ways by which you can solve these questions, although the answers are given to you, okay. So here as you can see, all these are basically the questions, okay. So the answers, the well balanced equation of all these equations that are word equations that are given to you is already given as the answers, okay. So I hope you have understood these questions. I know there are lot of questions that are left still. So that is all for this particular session. I know some more questions are left also. So we are going to do that in the next session. Okay, so stay tuned with us. Take care of yourself. Bye bye.